Okay, so this is how to use stoichiometry to find the empirical formula. Basically what we have is we have a compound that contains carbon, hydrogen, and oxygen. And we don't know how much of each of those there are. But what we do know is we have 10 grams of it, and we burn it, so it combines with O2, and we produce 14.43 grams of CO2 and 7.8 grams of water. So where did the extra weight come from? Well, it came from the oxygen in the air. Okay? So what is the empirical formula of the compound? These are steps we're going to take. First of all, we're going to find the percent composition of carbon in CO2 and percent composition of hydrogen in H2O. And then we're going to find the mass of each element, convert each to moles, divide by least number of moles. So basically the last steps, 3 and 4, are ones that we've already done. So if you want, you can print this out, but I'm going to do these exact calculations on the next slide. Okay, so what we've got is, this should be an arrow here. Okay. What we've got is burning 10 grams in oxygen produced 14.43 grams of carbon dioxide and 7.38 grams of water. So what we're going to do is we're going to find out of this 14.43 grams, how much of that is just carbon. So what we need to do is find the percent composition. Remember percent composition? We're going to take a carbon. Carbon weighs 12 grams per mole. You can just look that up on your periodic table. Divide it by the total molar mass of CO2, which happens to be 44. The mass of one carbon and 2 oxygens. You look it up on your periodic table. That gives us a percent composition of 27.3%. Okay? So of this 14.43 grams, 27%, a little over a quarter of it, is carbon. And remember, when we multiply, when we say of, we're multiplying, and we'll do that in step 2. Okay, next one, let's do hydrogen. So each hydrogen weighs 1 gram apiece. So what we want to do is find out, of the 7.38 grams, how much of it is hydrogen. So hydrogen, we have 2 of them in water. That weighs 2 grams. And H2O, mass of 2 hydrogens plus 1 oxygen, weighs a total of 18 grams per mole. Okay, and that gives us a percent of 11.1. Now, of the 7.38 grams, 11% of it is hydrogen. So let's go down here at the bottom. 14.43 grams of carbon times 27.3% equals 3.94 grams. So now we know of that total, of that starting amount of 10 grams, we know 3.94 of it is carbon. Next, 7.38 grams times 11.1% equals 0.819 grams, and that's the hydrogen. Okay, so carbon plus hydrogen. Now again, we know the total is 10 grams, so carbon mass plus hydrogen mass doesn't equal 10. What's the remainder of it? Well, oxygen. Okay, so if we can add these up and then subtract it from 10, okay, that'll give us the mass of oxygen. So what that gives us is oxygen is 5.24 grams. So mass of oxygen plus hydrogen plus carbon equals the total of 10 grams of the organic molecule. Okay, so we figured out how much the mass of carbon there is. We figured out the mass of hydrogen. We figured out the mass of oxygen. So this is just exactly what we've done before. We're in familiar territory. Remember the three-step problem we had before for empirical formula? First step was to convert grams to moles, then divide each by the least number of moles, and then round is the final step. So that's what we're going to do. So we had 3.94 grams of carbon. And what we want to do is convert that to moles. So the molar mass of carbon is 12 grams per 1 mole. And that's going to give us 0.328 moles of carbon. And then we'll do the same thing for hydrogen. 0.819 grams. And hydrogen is 1 gram per mole. And that's just going to give us the same number. Notice I'm making sure I keep my sig figs. And then the last one is the oxygen. 5.24 grams of oxygen. And oxygen weighs 16 grams in 1 mole. Okay, so we just have 1 oxygen. And that's going to give us 0.328 moles of oxygen. Now, last step, divide each by the least number of moles. So, 0.328, 0.819, that's carbon, hydrogen, and oxygen is 0.328. So we're going to divide each of these by the least. So okay, and that will give us, I kind of put the answer up here, make a little room. Alright, so that will give us, dividing these two, will give us 1 carbon. Dividing these two will give us 2.5 hydrogen. And dividing these two will give us 1 oxygen. So, we have 2.5. What are we going to do? Well, we're going to multiply this by 2. So that'll give us C2. H5O2. And there is our empirical formula. And we'll practice these in class.